Good evening, everyone, and welcome to the 38th edition of Data Bites, Getting Things Done with Data in Government, a defence special supported by Palantir. I'm Gavin Freegard, Associate at the Institute for Government, and it's wonderful to welcome so many of you this evening here at the IFG and online. Let's start in the usual way. Hands up if you've been to Data Bites before. Welcome back. Hands up if this is your first Data Bites. Welcome. And it really is wonderful to welcome so many of you to the building tonight. Not the well-targeted strikes you were probably expecting at a defence-themed event. I'd like to say it was by design that we chose today rather than our usual Wednesday, but actually I've never been so pleased that the IFG was double booked. It's also a complete fluke that we have an event on one of the few days with no strikes next week, all about government data sharing. So I look forward to seeing you all there. No excuse. Tonight's event is also, in its way, all about sharing data, as we have 4 excellent presenters sharing their data projects in defence, intelligence, and the Royal Navy. We hope this Data Bites helps put some interesting work on your radar, beyond your usual silos, that our light-hearted quickfire format proves nautical but nice, and you have the maritime of your life, if those puns haven't given you a sinking feeling. Just be glad I spared you another sea shanty. Let's start with the usual housekeeping. Tonight's event is on the record and we are being live streamed, obviously. On social media, it's hashtag IFG Data Bites and we are live tweeting from @IFG Events. If you're here in the building, the Wi-Fi is IFG Internet Hotspot, password Institute123, all lowercase. And as ever, I'll be putting your questions to our speakers. If you're watching online, use the Slido page you're almost certainly already on. If you're not, go to bit.ly/SlidoDB38, capital S, capital D, capital B. If you're here at the IFG, you can, of course, raise your hand, as well as surreptitiously using Slido to ask the more awkward questions. Why does IFG organise Data Bites? Well, we aim to bring together the various different data communities in and around government to show everyone what better data can achieve in practice and to put interesting data projects on the record so we can all learn from them. How does Data Bites work? Well, you're going to see 4 presentations about data this evening. Each presentation will last for 8 minutes. Yes, just 8 minutes. There are 8 bits in a byte, hence 8 minutes in a data byte. The presenter will then face questions for 8 minutes. Yes, just 8 minutes. And then we'll move on to the next presentation. So 4 presentations of 8 minutes, each followed by questions for 8 minutes. This is our 38th Data Bites. You can watch the previous 37 on the IFG website. If you're thinking it's not been very long since the last Data Bites, it feels like Groundhog Day, then you're right. It's only been a week since the last Data Bites, and today is, in fact, Groundhog Day. If you're thinking it's not been very long since the last Data Bites, it feels like Groundhog Day. I'll spare you that one. Given it's only been a week, I was worried there might not be anything for me to talk about in my introduction in British politics. I needn't have worried. We'll come back to some of that shortly. Now, today marks 100 days of Rishi Sunak as Prime Minister. He's only the 56th of Britain's 57 Prime Ministers to reach that milestone. And here you can see when he'll overtake the next few in that list through to the latest possible date of the next general election in January 2025. But of course, the big political story of the week was about someone who won't make it to 100 days in their cabinet post, Nadine Zahawi, sacked by Sunak on Sunday for breaking the ministerial code. Now, usually when it comes to ministerial departures outside reshuffles, we rely on our hardy perennial resignation chart. Talk about Groundhog Day. But that doesn't include sackings, so we'll need to turn to this one instead. The end of the Johnson premiership really is enough to drive you dotty. The larger circles are cabinet resignations, the smaller ones are junior ministers. Now, before I show you the sackings since 1979, it's worth saying it's not an exact science. Ministerial sackings are an irregular verb. I resigned so as not to detract from the work of the government. You are going to resign before I sack you. They were sacked in disgrace. They're actually quite rare outside reshuffles. We had one under Thatcher, appropriately enough for tonight, Junior Defence Minister Keith Speed refusing to accept cuts to the Navy. We don't get another until Defence Secretary Gavin Williamson was sacked by Theresa May in 2019. We get 2 under Boris Johnson, as many as in the previous 38 years, and again, one of them, Johnny Mercer, in a defence-related role. We get 2 under Liz Truss, though there's an argument that that resignation you can see, Suella Braverman, should also count as a sacking, and then, of course, Zahawi under Sunak. Now, there's speculation that we could get another departure with the investigation into claims of bullying by Dominic Raab. And this is when someone from the audience tells me that he's already resigned or been sacked, isn't it? I did come prepared, just in case. Now, the Lib Dems have called for Zahawi to resign as an MP, which would force a by-election. Here are all the by-elections since 1979. The party that held the seat before is on the top. The one that won it afterwards is on the bottom. Now, if we highlight just those that changed hands and focus on this Parliament, you get some idea of why the Lib Dems might be quite keen on a by-election in a previously safe Tory seat, given they've won 3 of them already this Parliament. Now, the next by-election is actually next Thursday in West Lancashire. It's been a long time coming. The previous MP, Rosie Cooper, announced she was standing down back in September 2022. Back then, Liz Truss was still Prime Minister, Kwasi Kwarteng was still Chancellor, Jodie Whittaker was still Doctor Who, Elon Musk merely used Twitter rather than owning it, and Arsenal were only 1 point clear at the top of the Men's English Premier League. How things change. And how that is going to come back to bite me when we throw it away before the end of the season. Now, had British politics not obliged, I did have a rather good fallback option for this introduction. For this week saw the launch of the IFG's 10th annual Whitehall Monitor Report, our chart-tastic chronicle of the civil service year. You can find the full thing, all 71 charts, on the IFG website. Among other things, you can see how successful government has been in bringing down civil service staff numbers, how successful it has been in moving civil servants out of London, how successful it has been in controlling civil service churn, and how successful it has been in improving staff engagement. Who knew Dominic Raab worked in so many departments? Now we turn to the really engaging part of the evening, and the speakers at this are Defence Special. First up, joining us virtually, will be Anna Knack from the Centre for Emerging Technology and Security at the Alan Turing Institute on their recent report, Human-Machine Teaming in Intelligence Analysis. We'll be back in the room for our second speaker, Palantir's Cameron Douglas, who'll be talking about how to maintain vital control over sensitive data. After that, we'll hear from Commander Sue Seagrave, who has possibly the best job title in the history of data bytes, Data Sheriff for Royal Navy Project Renown, and possibly one of the best titles as well, which is growing the data posse to improve Royal Navy ship availability. And finally this evening, we'll hear virtually from Ben Holloway, Head of Royal Navy Digital, who'll wrap everything together by discussing the scaling challenge. Our next Data Bites will be at 6 p.m. on Wednesday, the 1st of March. Then we'll be back on the first Wednesday of the month for April and May, and the first Thursday of the month for June and July. But do keep an eye on the IFG website and sign up to our newsletter and events emails, as I have a feeling there might be a bonus event appearing in that list very soon. You're good, you can come back. A huge thank you to Palantir for supporting tonight's event. They also supported our local government Levelling Up special in December, and they'll be supporting next month's health special as well. We need sponsors to keep Data Bites going, so if you'd like to follow Palantir's example and sponsor an event, please get in touch with my colleague Pritesh. And obviously we need speakers to keep the series going as well. So if you would like to speak or know someone that should, please get in touch with me. That's more than enough from me. On to our first speaker, which will be Anna, joining us virtually.
Hi, everyone. It's a pleasure to talk about our recent study in the Center for Emerging Technology and Security at the Alan Turing Institute on human-machine teaming in intelligence analysis. We tried to understand what the requirements are for developing trust in machine learning systems to help operational intelligence analysts. Specifically, the research aims were to understand where ML would bring most utility in the intelligence analysis workflow, or where it could in future. The technical and human considerations associated with embedding an ML system within a complex and high-stakes decision-making process, but also how the technical attributes and behavior of the model need to be explained to different types of users to provide sufficient confidence in the system. So in order to do this, we asked operational intelligence analysts, defense and security research organizations, legal experts, behavioral scientists, how a trustworthy system in intelligence analysis that leverages ML might need to be built. And our interview respondents said that ML has most value and would bring the most return on investment in the characterizing, discovering, and triaging information stage of intelligence analysis. So further left of the funnel, and further right of the funnel, where you get more into ML informing decision making more directly. Our interviewees said that this is more of a high priority area for your human intelligence analyst. Came out really prominently in the research is the importance of context. So you might have a recommender system that's, recommending film choices and song choices, but that's quite different to the context that intelligence analysts operate in, and it could differ as well, like depending on the role of the intelligence analyst and in what particular context they're operating in, how urgent the decisions they're feeding into, how high priority the operation is, and what the potential perceived impact of the decisions that they're feeding into could be on resources and human rights. There already is a lot of literature on explainable AI, and there's broad recognition that there's an issue around the lack of technical explainability of many ML systems. But when we did our literature review, it was really apparent really early on in the study that these mathematical technical explanations wouldn't really help analysts understand the behavior performance of a model if they were kind of hired for a different set of skills. Like they wouldn't necessarily understand the jargon or all the formulas that there are in the state of the art in explainable AI. So what we found, although we originally started with the study thinking that, we're looking for what the appropriate type of ML output would be an associated explanation that could give an analyst confidence in the output. What we ended up finding is that what you actually need is not just trust in the output, but trust in an entire system, which involves a lot of different explanations for a lot of different process owners. And you'll see kind of three broad bucket categories on the screen. The first kind of broad type of explanation is for the senior responsible owner. So the person who is approving the deployment of the ML-enabled system in an operational environment might need to understand things like, what are the system limitations and assumptions? How has it performed historically? What's it supposed to be used for? How is it accessing data? And what's the proof that it's necessary and proportional? Intelligence analysts on a day-to-day basis really just want simple explanations in plain English that they're able to interact with in order to kind of, in a layered interface, understand, okay, so what's the output? How has it been classified? And if they wanted to delve into it, they could look into how, what were the indicators that led to this recommendation? And also similar kind of to that first black box, understand system limitations or assumptions, system performance, but also potentially an opportunity to provide feedback to the system about how useful certain recommendations were or classifications. And then that last bucket is for oversight bodies, looking at logs, recording, analyst sense making. So at what time did the analyst make this decision based on what type of output on the screen, and also audit trails attributing used systems to actions. It was really apparent that on the user interface, this would need to be context specific, but also user specific. So different types of intelligence analysts might have different needs. And as I said earlier, interactive. But also that the complexity of the explanation provided needs to be commensurate to the complexity of the problem. So if you're giving a pretty innocuous recommendation, you might not necessarily want a detailed explanation. But if you're looking at, combining lots of different data sets to make a recommendation about military actions or, like decisions that lead to arrests, et cetera, then you would need quite a lot of explanation and granularity. We also found that there's a real need to be standardizing the language explaining kind of things like false positives, precision and recall, but also making that accessible to non-technical audiences in plain English. I think there are also like really important decisions that need to be made really early on about what would be the more costly type of error in any given context. So, if you were in a situation where you could afford to kind of get things wrong because it's more important to prevent an attack or to prevent a counter operation, for example, then you might have a different type of tolerance compared to if you were using the system to inform military action or, a particular target. And that appropriate threshold is really difficult to get right and would need to be established by engaging directly with analysts and users. I think there's also a piece about it not just being kind of like the perfect output, but also helping analysts understand what they're looking at and providing data science as a support service. So asking analysts, enabling analysts to ask questions if they don't think that the model's behaving like they would expect. And also a piece on kind of training and providing learning materials so that analysts can have like the minimum level of data science and ML literacy to be able to operate these systems in a trustworthy system. And with that, I can take questions, and anything that can't be covered today, I'd really welcome questions through the email on the lower right-hand side of the screen at ctas@turing.ac.uk. Thank you.
Thank you, Anna. And we've now got Anna up on screen. Just to remind those of you watching us online, if you'd like to submit a question, it's on the Slido that you're probably already on. Otherwise, it's bit.ly/SlidoDB38. I've had a fantastic question in already, but it's all about health data, so I might save that one for next month. If you're here in the building, we will come to you in the room for questions first. Remember, we are on the record. Do tell us who you are and where you're from if you can. Wait for the microphone to come to you, and we will be up against the clock, so please do keep your questions short. So, who would like to ask the first question? Go on. Somebody must want to. We've got one down at the front, right here. Just wait for the mic a second. Yep.
Hi, I'm Sue, and I'll be speaking later on. There's quite a lot of research on how the presentation of information, even the same information, can bias the decision. So the same probabilities can skew effectively people to take a different risk-adverse or risk-seeking. How do you think you mitigate that as you build the design of the interface?
Yeah, this came up in the interviews as well, and so based on our interview data, it was recommended that it'd be important to kind of involve behavioral scientists to really kind of identify how you could mitigate some of those cognitive biases, because when we asked the analysts, they pretty much was like, why are you asking us? Like, there are people who understand psychology and behavioral science a lot better than we would about specifically like what needs to be in the interface and what kind of like how it should be visually presented to them. There are kind of hints in non-defense sectors as well about how this has been mitigated. So for example, one sector that comes to mind is medical AI. There are some diagnostics decision aids tools that are already available. And, some of them might say, okay, so I've diagnosed the situation and classified it as this type of, say, disease. But just so you know, 70% of the time it is this, but 5% of the time, similar symptoms actually end up being this diagnosis, and kind of giving options or presenting kind of different alternative explanations for the classification has been seen to be helpful. Another way that one of the behavioral scientists we spoke to said might be helpful is kind of almost design these systems to be argumentative, or to continue to kind of challenge the assumptions made by the intelligence analyst. But there's a really kind of like difficult line to tread there, in that you don't ultimately want to get in the way of them doing their jobs well and kind of interrupting flows of thought or the way that they build the puzzle. So all of that, I think, like you could have different ideas of like different ways of presenting the information on the graph, on the user interface, but ultimately you won't know until you've tested it. So I think another really important point that came up through our research is that you need to kind of, in an iterative way, iron out what would actually work really well and what actually enables confidence and trustworthy systems by just trying it out in an operational environment and seeing what works and what doesn't work, and then identifying ways forwards and how you could potentially reduce error rates, or how you could potentially just help intelligence analysts make better assessments.
Brilliant, thank you. I'm going to go online for the next question. I'll come to you next. Question from Jeremy. Good evening to you, Jeremy. Do you think an ML expert is the best person to talk to the intelligence person, rather than trying to get the ML to explain itself?
As in a human ML expert?
I think the machine learning system itself, rather than an expert.
Sorry, I'm not sure I understand the question exactly.
I think, yeah, one could read it either way, isn't it? I mean, basically, should the ML expert or the ML explain itself, I think, might be the best way to interpret it.
Yeah, I mean, for sure. I think it needs to be both, right? That was kind of what we were getting at, in that you do need the data scientists to be able to explain as well, like what the system's trying to do based on what kind of data, and to make the necessary adjustments if and when you need to. But it's also helpful for all the clarifications to come from all directions, and to really like create a supportive infrastructure around the deployment of these systems. So you're not just relying on what you're seeing on the interface to explain how the system works.
Great. In fact, Jeremy's clarified, I meant a human to explain the output. So.
Yeah, exactly.
Great. I'll come to the room next.
Tom Coates, Office of the Chief Scientific Advisor. In this setting, to what extent should the user interface surface not only classifications or recommendations, but also the confidence with which those are made?
No, I think that's really important. So in the report, there's a lot more detail about all the different types of ways that you could kind of calibrate the trust that the user has on the recommendation or the classification. And that's one of those things. Like there's a lot of literature as well talking about, like, is it better to give percentages, or is it better to give kind of, I'm highly confident that this is, that this is about right, and not. And I think there's still like what type of assess, or what type of like qualification you give is still up for debate. But it's definitely an area of further research that we'd be really interested in doing more of in the Alan Turing Institute as well.
Great, thanks. We've got time probably for one more question, so I'm going to go online. This is to Sean. One of the current challenges for human-machine teaming lies in assessing the performance of machine teammates. Do you think we'll ever get to a stage where this will be close to how humans react to a situation, or not?
As in how close like human-machine teammates are to how humans react?
Yes,
I think in a given situation.
Yeah.
So based on the views that we interrogated through the interviews, there was a lot of skepticism about ever getting to that point. Like one of our interviewees, for example, said that really there's a lot more appetite for faster horses rather than, like really complex, decision support tools at the moment. Will that change in the future? It's possible, but I think there's a lot with the kind of less complex ML systems that still needs to be ironed out before you kind of get to the concept of a human machine teammate, which also came up in our interviews. So one of the behavioral scientists we spoke to, for example, said that the real difference between a teammate is that it's trying to do a lot more than just like simple classification. It might be a teammate that's tries to back you up, or that gives you reminders that could maybe calibrate to your working style. So if you're an analyst, cognitive overload is one of the things that you're trying to kind of manage at the same time as trying to get through as much data as possible. So maybe at your optimum level of cognitive performance, maybe the system will try to challenge your thinking a little bit more or interrupt your work a little bit more, but then maybe in less performant times or kind of in the more suboptimal times of your working day, maybe it'll try to interrupt you a little bit less. There's all sorts of kind of also like blue sky thinking on like what a human machine teammate might look like in the future. That's also in a lot more detail in the report.
Brilliant. Unfortunately, that's all we've got time for. But Anna, thank you very much indeed.
Thank you so much. Hope it was useful.
And sorry to those of you online, lots of excellent questions that we couldn't get to, but as Anna said, do drop her an email and you can find the report online. Time for our second speaker tonight, and that's Cameron.
Cool. Good evening, everyone. Thank you for having me. My name's Cam Douglas. I'm a deployment strategist at Palantir Technologies, which means I try to come up with novel solutions to our customers' hardest data problems and work with them for the long term to try and solve those problems. Palantir has been working with the Royal Navy since 2014 to create a digital twin of the service that will help them make better decisions about operations, personnel management, equipment maintenance, and availability. The Royal Navy uses our platform, Foundry, to underpin their system that they call Kraken. Kraken's a system used by hundreds of naval personnel in a variety of roles to make critical decisions, ranging from modelling the workforce requirements of the force over the next 10 years, through to understanding root causes of engineering failures on board ships. All of these workflows are ultimately contributing to maximising the availability of people and equipment for the service. Naturally, all operational users on Kraken need to have consistency when it comes to accessing sensitive data, but how does that actually work? In this talk, I'm going to walk through the two main tools Royal Navy users are using to maintain world-class security-driven access controls, and then I'm going to explain how these tools empower users at the operational level and in higher leadership ranks. There are several layers of security and access control tooling within the Kraken system, from the data ingestion point right the way through to the point at which data is made available to users that allow for proper and efficient data governance. Firstly, the markings tool. Any access controls that exist in an upstream system are imported into Kraken and propagated through all of the data transformations in the pipeline using a tool called markings. For example, in an upstream HR system, you'll have a user profile, and that user profile stipulates what data you're allowed to see. Those rules will be inherited into Kraken, and the raw data will be marked with those same rules, and all of those rules propagate down through to the end state. Rule 101 is that you never lose any of your inherited permissions. That's the basis point from which you start, and it underpins how a lot of existing systems work in terms of role-based access, aka the data you're able to see is defined by your role and the data and permissions associated with that role. Our Foundry platform, which forms the foundation of Kraken, is valuable in this context because when you're integrating data from a variety of systems, you need to take a conservative approach. All of the various role-based rules need to be layered on top of one another so that by default the most restrictive data access is applied. Secondly, the PBAC tool, or purpose-based access controls. In a lot of cases, we find that the rules that are inherited from source systems are clunky or in some places don't exist. For example, some of the legacy inventory systems have been in service for many years, and the access requirements today are vastly different to how they were when those systems were bought online. It might also take a very long time to change the rules in the source system for technical or commercial reasons. The problem statement here is that you need to work flexibly, but within policy, to make changes to what an individual is able to see. To combat this problem, we've built a mechanism in Kraken that lets users request access beyond their role-based permissions and provide a purpose and a justification for why they need to see that data. Those requests are triaged and approved as appropriate by information asset owners. If approved, the asset owners can provide additional data to a specified individual with a defined purpose for a set period of time to allow them to go and deliver whatever outcome they're looking to achieve. This purpose-based data provision works down to the individual cell level. I'll provide a horizontal, i.e. row level, and a vertical, i.e. column level example to illustrate this. So first of all, the horizontal example. These markings and PBAC tools incorporated into Kraken directly benefit the working practices of Royal Naval personnel. For example, a Royal Navy branch manager will log into the platform and will only be able to access data on personnel within their branch. Meanwhile, somebody from 40 Commando Brigade will only see people who are relevant to their unit's permissions. Everyone will be looking at the same person object within the platform with the same properties across all of the services and all of the units, but only the rows relevant to their permissions will be shown. This is critical for maintaining a single version of the truth, whilst ensuring that all users have the information that they need in order to do their jobs. Secondly, the vertical example. Senior leaders in the Royal Navy need to see aggregated information about all personnel to inform strategic decision-making. But there are certain sensitive properties that they shouldn't be able to see, such as individual medical records. On the other hand, leaders in defence medical services require access to that data in the normal course of their jobs. But there is no reason for them to see the same operationally sensitive detail that the Royal Naval leadership sees. This granular permissioning is critical for numerous workflows in Kraken, but one of the most common is for understanding readiness. A unit commander needs to understand the deployability of personnel in their unit, but should not be privy to the sensitive details of why, for example, a certain sailor is undeployable for medical reasons. In both the horizontal and vertical examples, the platform incorporates different parameters based on specified permissions. It's clear that Foundry's marking tool and PBAC tool provide incredible amounts of flexibility that don't constrain the workflows and use cases within Kraken, whilst protecting the sensitive information of sailors. Allowing users to interact with all of the data that's relevant to them streamlines the way people are able to make decisions, driving impact across their organizations and increasing speed to value in truly monumental ways. Thank you. Take questions.
A reminder, if you're online, you can ask a question via bit.ly/SlidoDB38, and I'm going to start online. We've had 2 questions from Anonymous. I'm guessing, given that they're very similar, they're probably different people. The first one is, do you think that purpose-based access control could be applied in the context of public service citizen data? Could the information asset owner be the individual themselves? And the very similar question from the other Anonymous, how can the work being done with the Royal Navy be extrapolated to other data problems across the government?
Cool. I'll start with the second, if that's okay. So I think the tooling can be applied to other areas of government. I think where the combination of markings and purpose-based access controls is really powerful is in organisations and institutions where there's a very fragmented and brownfield data landscape. So part of the challenge that we've had on the journey with the Navy is the fact that they have systems that were brought online in the 80s all the way through to systems that are coming online today. And in order to allow them to really exploit that data, it needs to be brought together. And the picture with those disparate systems is extremely different, as you can imagine. So being able to layer that access controlling on top of that accumulated data is essential. And obviously that landscape is very similar in other parts of government. They are big institutions that have existed for a long time and have been through numerous transformation programs and have lots and lots of different systems. So certainly applicability, I think. And then to the first question, that's a really interesting one. I think in principle, yes. Hypothetically, yes. A lot of the challenges there would be around how that actually gets rolled out and the uptake associated with that principle. For an individual to be the information asset owner for all of their information, you would need an entire population to be brought into the process of making that data available, triaging their own requests. Certainly possible, but I think there's a huge amount of change management that would need to go along with it. But it's an interesting idea.
Brilliant, thanks. I'll come to the room for the next question. Question at the back there.
Hi there, thanks very much. Just interested if you think you could deploy a type of federated learning model to data sets almost anywhere to ask a question and go, this is data I would ideally like. Let's put the technology in place and use a payback system to be able to get access to it to then answer the question.
Yeah, again, that's really interesting. I guess in principle, yes, some of the challenges I think would be kind of linking back into the previous talk somewhat in terms of to what extent do you want a human analyst or other in the loop to actually be making the decisions from a kind of moral and ethical standpoint as to what is acceptable or not. And I think a lot of the things that Anna touched on are very pertinent there. But from a data integration and a technical standpoint, certainly that would be completely feasible.
Thanks. I'll go online for the next question as well. This is yet another Anonymous. How did you overcome the challenge of multiple systems extracting data and then updating data once decisions were made? It's such a complex landscape.
It is, yes. I won't eat too many of Sue's sandwiches because I think she will talk about some of this. But where to even begin with that? So I think the way that we went and still are on that journey with the Navy is tackling the problem by problem, decision by decision. There's not one solution that fits all for that problem because there are different data latencies depending on different systems. There's different timeliness at which people need to make decisions. There's different formats in which the outputs of those decisions manifest themselves. So certainly in kind of the early days of the journey of that Kraken platform, it was a case of identifying the problem, understanding what information was required in order to solve that problem, seeing what the outputs of that decision-making process were, and then meeting the needs of, you know, the lived reality of the individuals making those decisions in order to kind of close that information loop. And in practical terms, what that might mean is, you know, you cannot write it back to the source system because the source system was made in the 1980s and no one has touched it since then. And actually what you need to do is output the results to an Excel file that somebody can go and punch into, you know, the existing system in order to make sure that that decision propagates all the way down through to where it needs to be. So yeah, not a kind of a silver bullet answer, I guess, but it's very, very specific, I think, to the problem.
Great, thanks. I'll come in the room for the next question as well. Raise your hand if you'd like to ask it. Down here at the front.
Hi, Teresa Dümchen from Global Council. My question is, could you give us any examples of efficiency gains that you've already achieved through the platform? And secondly, do you think there are any next steps or future developments that could build up on this?
Sure. Is that specific to Knack and the work with the Navy? Yeah. So there are, again, I don't want to steal too many of Sue's sandwiches, but some of the more recent work that I've done on the program has been less to do with personnel and more around the kind of engineering and logistics, and the kind of the North Star, if you like, of that work has been all around trying to improve the availability of ships, and there are some statistics around the improvements that have been made. I think your boss was quoted as saying it was the equivalent of having two, sorry, I won't overstate, 2 and a bit additional ships, just by making sure that ships are not tied up alongside in maintenance periods. They're out at sea doing what they need to do, and when they're out at sea, they're not broken. And to the second part of your question in terms of where's it going next, a lot of the work to date has been quite reactive and risk-based and backwards looking. It's been really valuable. You know, it's moved things forward significantly. The next step on the journey is trying to flip that and be more predictive and forward-looking, and that, you know, applies both in the personnel domain, trying to forecast out what the, you know, what the skill requirements for the Navy are going to be over the next 10 years, but also through down into can we predict failures more efficiently? Can we make sure that we've got the things on the shelf that we actually need rather than, you know, stuff that's sitting there collecting dust for the next 15 years? So into that predictive space is definitely where we're going.
I'm going to squeeze in a quick final question from Anonymous. Has it ever gone wrong, coming close to allowing incorrect access, and what did you learn?
Great question. I think where it went wrong, or where it's come close to going wrong, was where we met the challenge of integrating systems that don't have role-based access. So there were certainly some challenges as we started to layer, you know, data from these disparate systems on top of one another, initially relying on the rules that existed within those systems. It very quickly became clear that that was not going to be feasible because people were getting access to too much information, and we needed to do something to mitigate that. So, you know, that was the genesis, essentially, of the purpose-based access.
Fantastic. Well, Cameron, thank you very much indeed.
Thank you.
And our third speaker this evening is Sue. Whenever you're ready.
All right. Good evening. My name is Commander Sue Seagrave, and I work for a project called Renown in the Royal Navy. I'm a marine engineer by trade. My current role is data sheriff. If you want to know what a data sheriff is, we'll have to save that to later because there's a scary timer just there. Renown, however, I am going to tell you all about. Renown is about improving the availability of our ships, which are some of the most complex and expensive machines on the planet. Complexity in defence isn't about one big decision, it's about lots of small, interlinked decisions that are time sensitive. By exploiting our data better, we aim to ensure that all of the small decisions meet that strategic goal of availability, such that the whole becomes more than the sum of its parts. There's a cheesy anecdote about a caretaker at NASA, and he's mopping the floor, and somebody asks him what he's doing. He says, "I'm helping put man on the moon." And that is the kind of focus on a common purpose that we want to build the Renown. However, what Renown is trying to achieve does come with some strategic tensions. The first of those is between surfacing how everything links to that common purpose while still restricting access to the data we need to protect. So Cam has talked about some of the technical aspects of how we do that, and I'm going to talk about the organisational challenges of implementing those. The second tension is between agility, speed, innovation, and building to scale. The former are all things that traditionally government is notorious for being bad at. And part of that is because it's easy to be agile when you're small and you're light and you don't have lots of dependencies. But to change availability outcomes, we need everybody, down to the most junior person, understanding what their role is. Because another lesson from NASA, specifically their Challenger disaster, is that things that seem tactical, like O-rings, are really sometimes very strategic. So to be able to scale and sustainably, we have to have control and be coherent. And then the third tension we have, that's between competition and collaboration. On one hand, we want industry competing to drive value for money and avoid monopoly. But to achieve quality, we need those industry partners to collaborate together, put aside their rivalry, and work as if they were actually part of MOD, but still in a way that's compatible with the obligations to their shareholders. Thanks to Project Kraken, Renown got access to the Foundry software product in April 21. I'm going to talk about now what we've learned as we've implemented it and how we've tried to overcome those tensions to improve availability. What we found in practice when it comes to the granular permissions that Cam's talked about from a technical perspective is that when we go down to that level of detail, our business rules conflict and they become logically incoherent. X is legally responsible for three-sided shapes, but he's not allowed to see triangles. A lot of our existing policies are written around the world where data is stored in filing cabinets, it's physical, and there's little interaction between standalone projects. That world has gone and our culture hasn't caught up. The complexity of our data, the number of systems, means that when we start applying fine grained controls, we very rapidly get an explosion in the number of combinations. We've had to try and find that sweet spot between controlling access and not having more permission combinations than there are bacteria in the universe. We have now nearly 100 companies working on the platform, and I think the lesson there for us is we need to think much earlier and in much more detail about what data access contract needs so that these permissions are baked in from the outset. If that access requires additional controls, we need to think about the overhead and the cost of accessing those controls before we start the contract. And what we're finding with technical controls is there's a bit of a toxic combination with data quality. When we set our access parameter around, you can see bits of data with this value in, and that's set incorrectly. There's a danger that the person who needs to be able to see that won't be able to see it, and we've recreated exactly the silos that we wanted to break. So, moving on to the next tension between speed and scale. The model we've come up with, we call pods. We set up our first pod 5 months ago, and we're now at over 50 pod. A pod started out as a word to symbolize the idea of working independently, but to a common pattern in a way that forms an overall coherent whole. But the military being what it is, nobody could cope with it not being an acronym. So now it's the patternized organic development model. The way we instigate a pod is a group will come to us with a user requirement. 2/3 of our pods are citizen-led and 1/3 professional. We'll undertake an initial assessment of their data requirements so that we can compare them with what we've got in the model already, and then consider what new data we wish to integrate. And then we divide those pods essentially into 3 categories. The simplest pod, and I'm going to throw in a Lego analogy here because everybody loves Lego. And if you don't, you shouldn't be here. Is a pod that simply wants to take the data Lego that we've already provided in their data Lego kit and rearrange it into something that's configured to their specific problems and decisions. We're finding that once they're trained, citizens can have something delivered and operationalized potentially in under a month when all of the data is already in their kit. And what we also find is those builds By parameterizing them, something that's been developed by one pod can then be rolled out to other less nerdy teams, normally the marine engineers. Our second type of pod is more complicated. They want to build from earlier in the pipeline, mix and match Lego bricks by doing transforms, using functions or deriving new attributes before they start adding into their front-end application. This is where we provide a coherence role to avoid proliferation of similar Lego pieces, or conversely, functions that are going to use excessive compute. As a result, we sometimes pair up and sequence the pods. The third and most complex pod is where people are wanting to integrate new data sources, add new bricks to our Lego kit. For those forms of pods, we need to think about granular permissions early, not just what the individual pod wants to do with the data, but to anticipate what all of the other pods and future users might want to do to exploit that data in the future. If we don't think about long-term permissioning structures, we'll incur technical debt that Cam warned me about years ago, and that costs us downstream when other people see what's being built and they want access to the cool thing too. The final tension I mentioned is between competition and collaboration. As well as Lego, I like a nice rugby analogy. Having both competition and collaboration sounds impossible, but there is precedent for it in successful professional sports teams. Professional sports teams compete for their place at the top, but when they come together to form the Lions, we expect them to put their rivalry aside and play together. We wouldn't pick a rugby team by reading a tick box form submitted by the player's agent on how awesome they are. We want to see them playing matches against similar oppositions and assess how they're going to fit in our team. At the moment, we've got 2 matches running in the form of professional pods with different industry partners, one for our Type 45 class and one for our recently upgraded 23. 2 pods share 80% common feeds, and then the goal of those 2 pods is integrate platform-specific sensor data onto the ontology and start building engineering the system models. From our perspective, a useful model is one that predicts the loss of availability in future and, more importantly, identifies interventions that are going to prevent it. And then what we want to do is take the best of those pods and others, combine the best techniques and the best players to a super pod and scale the approach and build a twin of our carriers and their strike groups. Vision is this is going to be a collaborative endeavour being built with multiple industry stakeholders using different inputs from different pods to generate the whole representation, but where the mod remains, the taxpayer remains in control of our data and is in the controlling mind of the overall output. Thank you very much.
Perfect. Thanks, Sue.
How long was I over? Excellent. It's only because I had to have a dig at you.
I'm sure there's a digital government Scrum Master joke in there somewhere as well. I will go online for the first question, so if you're in the room, do think about what you'd like to ask Sue. Anonymous says, the complex range of public citizen services also illustrates the implications of multiple small interactions on large outcomes for very valuable things called people. How might you apply all of the thinking that you've described in that context?
So we're already interested as engineers in people in the context of defence. I've been told off for calling them maintenance robots, but they are maintenance robots to me. But the approach that we are using is to look at how that interacts with the output. So I guess in the context of the question, this would be public services. And we were doing some work earlier today looking at some other uses of the Foundry software by other areas of government and commercial to see what ideas we could borrow from them and implement. I was being shown the Homes for Ukraine implementation and how that's been set up to deal very quickly with an influx of information. It's really interesting to see how a lot of the problems are similar. So they've got, in this context, lots of different local government areas, getting all of these forms, duplication of information because people apply multiple times by multiple different routes. And then sometimes they move around the country, so these local government organisations need to be able to share and pass their information between it. It was really interesting, and there's definitely a few ideas that I've borrowed from that, because the other thing that interests us is one of our big blockers is how we do money in public service. So Renown's original idea was taken from commercial shipping, where they achieve 95% availability, but they deliver one output and they optimize for that output. Whereas though we talk about monetizing availability, it's not, it's taxes and putting a ship to sea is a cost. So when we run out of money, we start putting that ship alongside. And at the beginning of the year, we divide our money into silos, and then the activity follows those arbitrary silos, and we're not very good at moving that money around dynamically without going all the way up, by which time it's too late. So we want to be able to veer and haul money, but still retain control and auditability of our taxes across budgetary areas. And that's kind of what they were doing with the local government.
Great, thanks.
Really interesting. Thank you.
And if you're interested in Homes for Ukraine, you can look at Data Bytes 36, where we talked about that. Have we got any questions in the room? We've got one at the back there.
Hi, thanks for your talk. My name is Chuks. Given the critical nature of your work, I would like to know how you deal with data quality on your platform.
As I said, what does a data sheriff do? And that is definitely a big part of it. So we have huge data quality issues, a lot of which date back to some of the system and the age of some of the systems. And some of it is also formatting and compatibility of formatting. What we're trying to do is build real-time data cleaning loops. So we evaluate against the model that we have, the activity stream that is coming in. So imagine a job part tells somebody to renew something or do a repair job, and it has 10 things listed on it. We then look at what is ordered against that job, and at the level of each component, we want to look at what the reason for the difference is, and then what we're trying to build is build a kind of a predictive recommendation that I think the reason for this different, or what Foundry thinks is the reason, most likely reason for the difference is A, then it's B, then it's C, and if it's not sure, then the human. And then as it collects that loop, and eventually, potentially, as we gain confidence in it, and our measure of effectiveness is the delta between what the model predicts and what our demand signal coming in says will happen.
Thanks. If you're online, a reminder, you can use Slido to put your questions to Sue, and it's bit.ly/SlidoDB38, capital S, D and B. Let's stay in the room for the next question. Hands up if you'd like to ask a question. Otherwise, everyone online is going to have all the fun instead. Okay, I'll go online for the next one in that case. Anonymous asks, how long do you think it will take for MOD to adapt a Foundry style platform at scale, not just in the Navy, so we can start doing more things with the data like machine learning, etc.?
Excellent question. A lot faster, I think, than people think. So the Royal Navy, I'm clearly biased, is the most joint of the service. So we have the Fleet Air Arm and we have the Royal Marines. So the scope of Kraken has always been the whole maritime enterprise. And when we deployed, so I mentioned the Carrier Strike Group, when we deployed that strike group back in year before last, 2/3 of the material, both in cost and in volume of things, that came out of it actually came out of the land and the air domains within defence equipment and support. So for us to improve availability, we actually do have to look already, and we are looking already at that joint aspect. Up until now, we've been commercially prevented from going into the other domains, but we're now allowed, with the announcement before Christmas, the enterprise contract, to start moving and deploying the software there. So we will be looking at that a lot. And we've got a whole bunch of projects, starting with assets like boats, which are very joint. Believe it or not, even the RAF use boats, but most of them in the maritime. So that will be an example of an area where we'll try and start with a pilot and then scale it up.
Great. Anonymous says, no question, but I just wanted to say how envious I am of your role title. Who in the room would like to ask the next question? We've got one there.
Okay, this question might be really stupid. I'm Paula, I'm nobody. I'm just here because this is interesting. What systems do you have in place to avoid corruption or to have like some sense of accountability in case information gets into the wrong hands because of either active corruption or human error?
So the risk balance case is around security. So there's something called the mosaic effect, and there's a real tension for us how much we aggregate at what level of classification. So the risk balance cases and what we open up the data to are really carefully considered, and actually what we have is much more protection, because at the moment what's happening is our information goes out to industry, they store it on their systems, they process it on our behalf, but we can't see what else they're doing with it, and we can't see. In the platform, everybody is watching you. I use it at the moment to monitor user adoption, but actually you can see everything everybody has done, what activities they've had on a project, who's consuming compute, because that's fundamentally how it's paid for in the long run, so which projects are using it. So through that, we can monitor the behaviors and who's using what data, and then we're linking to as robustly as possible. At the moment, it's very fragile because we haven't got direct link to the HR system, but ultimately we want to automate the permissions to you being in post and remove permissions once somebody... So a lot of systems are quite good at checking on the front end. They're less good necessarily about taking things away. But it gets very complicated with contractors, particularly when they move from one contract to another. They're potentially on 3 contracts simultaneously, all of which give different data accesses and expire at different times. And that's another thing. I don't get to do the fun stuff. I end up doing all of the boring but really important stuff that enables us to maintain that. And I've used up all my time again. No one saw that coming.
But we've had great fun in the process. So thank you very much, Sue. And we're going virtual again for our final speaker of the night, and that is Ben. Hello, Ben.
Hello, everybody. Hopefully you can see my slides.
We can indeed. Over to you.
Excellent. The system works. Thank you very much. Thank you very much, everybody. Ben Holloway, Head of Data and Navy Applications. 2 jobs. The Navy doesn't have a Chief Data Officer. It has a me. And the other half is I run the Navy software house. So we'll talk through today either, depending on your outlook, the scaling challenge or the compounding benefits of the choices that you decide to make really early on. First off, a little bit of context around this thing. So historically, the Navy has thought about capability in terms of a specific platform, a ship, a submarine, an aircraft, and that will go off and do a thing. And it contains all of the systems, all of the sensors, and all of the effectors that it needs to go and achieve a certain task. But what comes after platform-centric capability approaches? Well, we've started to think in terms of a systems of systems approach. The idea that you could sense something in one particular location with one particular unit, you could decide, you could pass that sensing, the information back somewhere else, and then you can make a decision in a completely different environment to where your sensor's taking effect, and then deploy an effector that might, again, be from a completely different platform. That gives you much more flexibility around the way you not only operate your force, but the way you buy your platforms and various other bits and pieces. Fundamentally, as I've said already, it's focused on sense, decide, and effect. Now, I don't hopefully need to kind of spell it out to everyone in the room, but hopefully you can see that unless the sense, decide, effect is entirely taken up by a person, this is a data problem. That whole decision space in the middle there is an entire data problem. So we're approaching this also building on the back of a series of innovators, demonstrators, proofs of concept, and things that we've tried. So first off, before we start down that path, we'll look at the lessons from our demonstrators and pilots. What did we identify? Now, the top one here sounds really obvious, but you'd be amazed how often it catches people out. Problems are rarely as easy to solve as it first appears. We need to challenge every assumption we're making when proposing a solution to a particular problem. You want to implement a COTS solution for something? Where do the users need it to be deployed? What data does it need? Do you have the data? Does the data exist? Can you get access to it? And if it goes wrong, who owns the risk? And this kind of speaks to some of the questions that have already been asked tonight. The second one's about doing everything with a customer who is trying to achieve an effect and use them to keep you honest about delivery. What will be delivered for them by when? There is nothing more important than the benefit you're trying to deliver. That is why you are doing this thing. Consciously and deliberately manage your technical ecosystem, lest you end up trading one set of silos, be it in source systems of record or in data departments, for another set based on the technologies you've chosen. Doing so will allow you to develop common reusable components and really accelerate your delivery. We talk about agile delivery a lot, but do we really mean it? And how do you make that sustainable? Deliver benefit quick, then iterate. This maintains the trust of the user base, or so we found so far. Too often, jam tomorrow actually really means no jam. And then always be conscious of the imperative to deliver and do so quickly. The operational situation, particularly for us, may not be willing to wait for the technical perfect solution. Sometimes technical purity needs to give way to practicality. If you can meet a need quickly, you should do so. So having identified these lessons from our incubators, from our proofs of concept and our pilots and demonstrators, people still had problems. We needed to deliver. We needed to learn from these lessons we identified, but we still had an eye on scale. This is really where it is. So making the singular approach scalable. On the left-hand side, you'll see what is probably the traditional approach. And this is a bit of a story time here. I imagine everybody in the room has their own story. Either something from your work life. Either someone approaches you with a question about their job, how do I find out X, or how can I do this better? Or you accidentally learn some horrific inefficiency occurring in the office next door. Either way, you feel obliged to help, so you do so. It doesn't seem like too much of a demand or a problem. It works, and whoever you helped is really, really grateful. They tell their friends. Now, this is where the problem comes in. This is the cost of your success coming back to bite you. You help someone else, and then probably somewhere else. But if you're doing this as a starting from scratch each time, as its bespoke solution, there's potentially no support solution for you to hand off these finalized products to. And if they're not one-off use, if they're not throw away, fire and forget, then people have a level of expectation. You've provided them with a product that's now rapidly becoming a service. And that's from a user perspective. From your perspective, presumably, starting from scratch each time is really rather tiresome. So that's the left-hand side of the screen. On the right-hand side of the screen, you'll see the approach that we have taken in trying to avoid that. We want to maintain the individual approach Cam mentioned earlier, focusing on problem by problem or decision by decision. That gives you that laser focus through to a user requirement. We wanted to maintain that, but we didn't want to have to start from scratch every time. We didn't want to have to rebuild every time, and we wanted to be able to support these things coherently through their natural life. And so we adopted a more of a data platform type approach. You've already heard plenty about Kraken, so I don't need to go into it too much. But fundamentally, this is about connecting our source systems of record as and when we need them to support the development of individual use cases. It's about ingesting that data. It's about transforming it and integrating it with the hundreds of tables that generally make up our source systems of records with themselves, to make sure that we are representing an accurate picture of what exists in that system of record, because the data is not always of decision quality. Identifying where there are problems, enabling people to go back and fix those problems at source, but also integrating the data with new systems. So you can see here in the simple diagram on the screen, you can see that where you adopt a new red use case, you don't have to build your 3 data sets, you only have to build 2. And that's the compounding benefit that you get. What we then did was we've modeled all of that data out towards our ontology, our kind of network of connected business concepts, and allowed users where their permissions and use case and need align, to navigate between those things, to not just consume pre-produced, productionized products, but to do something ad hoc. Promote laziness as a virtue. If these people can automate something in their jobs and go home early or go and do something else or make more decisions in a day, surely that's a good thing for us. And then those use cases on the right-hand side of that screen. That's everything from a desk level person who is making, or 100 desk level people who are making 1,000 decisions a day, but they are highly repeatable. You can, but nevertheless need a human in that loop. that acts as almost a virtuous cycle of self-validation. They know the data in a way that nobody else does. And so in doing that, you end up with a constant validation cycle over and above the normal governance and management routine you might have in the organization. So when you do have to produce something for a very senior user, and you need to aggregate up some of those desk level data feeds into something that they will understand, you can absolutely do so. And you can do so safe on the knowledge that you're building from a really secure, validated, and accurate data foundation. Ultimately, what you're doing is that line across the top there. You're reducing duplication, you're increasing reusability, and you're ensuring data discovery. This is complicated, it is not complex. I've put some points at the bottom there. These are key elements that are important for you to be able to nail down if you want to adopt this approach. I'm not going to go into them in too much detail. You've heard from the previous presentations the importance of product and data security and how you might apply different types of controls to ensure that only those users who have a need and have a right to access that data can do so. I've already talked about the need for live support and the expectations of a user. Management and governance we've talked about, and technical coherence I've linked into already. So a quick use case to give it to life, or bring it to life. This is a relatively recent one. A senior leader in the Royal Navy, thinking about an ever-increasing number of topics, both routine and ad hoc, felt that his decision-making was being held back by the inconsistency, the variation, the lack of responsiveness, both in terms of the products he was seeing and in the organization. He wanted to see a number of workforce views, finance views, ship availability, safety, cyber risk, all in a single automated product built exactly to his needs. And challengingly, he wanted it in 2 weeks. With that kind of timescale, we adopted the Reddit model of delivery. On the basis that there's no quicker way to get to a right answer than publish an opinion on the internet, somebody will definitely correct you. But even with a build and correct style of model, connecting to systems, ingesting data, transforming it, and establish a data validation cycle with the contributing departments would be impossible if you started from scratch. Using the validated data already supported, supporting a number of workflows already in Kraken, and therefore only having to ingest new data from a couple of systems, we were able to provide the customer with an MVP in 6 days. That was the opinion session. We took his feedback, validated at desk level and with the departments around the business logic we were demonstrating, and then provided him a product in just under the timescale. And hopefully that brings it to life. Short and sweet, on to questions.
Thank you very much, Ben. While you come up on screen, there you are, perfect timing. If you're online, it's bit.ly/SlidoDB38. And if you're here in the room, you can limber your arms up ready to ask a question. And we have a hand already over there.
Thank you. Paul Maltby from Faculty AI. Faculty works across defence and central domestic government. And for someone like me that's come from the domestic government side, it's just really interesting both for Ben's and the other talks today, the extent to which the understanding of the opportunities and the limitations and just the practical application of some machine learning in operational decision making feels ahead on the defence side compared to domestic government. I'm interested, Ben, in your reflections if from where you sit, does that feel true? And what's your message for those senior leaders in operational businesses in the, if you like, the regular civil service side?
Yeah, it's an interesting question. I would say it's true in places. I would say it's not true in others. Defence is a massive organisation, and if you think about that in terms of our use cases with data ingredients, some of those use cases are really quite sophisticated and advanced. Some of them are not. And so I think it's a case. I think it would be wrong of me to say that Defence is ahead or the Navy's ahead. I think we have some really, really good news stories and some some examples to be able to share with wider government. But I don't think that's universal. I think it would be kind of wrong to kind of claim that in some regard. What it does probably give us is, having started a couple of times and having done all right, it gives us a really good springboard from which to develop on. And so, as with the kind of compounding data model I just talked about, actually you already have models of governance structures and things like that work. You already understand how it works. So ingesting new data, you can imprint a governance and management mechanism out with a particular technology type. based on something that you've already implemented in another area. So that's probably the first bit. To the second part of your question about what would I say to leaders in other areas, I think just pick something and try it. I think there's a little bit of you just have to pick a problem and go after it. Pick a problem, pick an effect you're trying to have. What's stopping you from achieving that? What decisions do you need to make in order to achieve that thing? What information do you need to make those decisions in context? What data do you need to generate that information? And once you've got a bit of a chain there and you've got a laser target on the thing that you're trying to affect, go for it.
Brilliant, thanks. We've got a question from Anonymous, which is, you talked about the challenge of iteration and agile in a world of waterfall and scrutiny. Can you talk about how you're tackling this with your governance?
This is tackling is probably a reasonable word. This is a relatively continuous gift. It certainly keeps on giving. I think we have learned a lot in coming as far as we have. But we're still fundamentally presented with a problem where a user will come to us with a problem, and if it's something where they have to bring funding and we have to develop a thing for them, we'll end up going to finance and scrutiny panels, and they'll say, yes, I get your agile delivery thing, but show me your level 0 plan out for the next 5 years. Excellent, thank you very much. We are starting to get a different model in place, an agreement with our finance, commercial and scrutiny partners, which is actually around our operating model. So the way that we do our agile development is really critical, and the way you track your development is really critical. You need to be completely open and transparent about the speed of velocity, the things that you're doing, where your money is going, and you do actually need to hold to some of the agile principles. Too often, agile means don't write it down in the minds of people who are the naysayers. Whereas, as we all know in the room, you get to the end of a project, if there ever such a thing, and by that point, you've written down almost exactly the same amount of stuff as you would have done if you'd delivered it in a waterfall way. You've just done it spread out through the life of that project or that delivery, as opposed to all right at the start in a pane of imaginative fabrication. So I think solving it again, we're on the journey. We're not quite there. We are getting there, and the thing I would say is, I'll come back to it: transparency, and show your workings. Show your delivery velocity, show your backlog, show your prioritization mechanisms, show where you are delivering things and where they're adding value. Get your MVP out as quickly as possible into the hands of users so they can start accruing benefit. And don't be afraid to, if it looks like it's not going well, kill it.
Brilliant, thank you. I'll come back in the room for the next question. Hands up if you'd like to ask it. Otherwise, I'll go back online. The next question online is, how do you negotiate legacy technology?
Constantly. I think the reality is that so we don't live in a greenfield world. Everything is very, very brownfield. Some of our systems, as I'm sure Sue will say later on to you in the room, were conceived and born, if you like, on a date that's closer to the end of the Second World War than it is to today. And they're the things we're operating with. What we have to do is understand the limitations of each and every one of those systems, and the restrictions that we kind of inherit from them. We try and replace them wherever possible, or subsume them into something else, something better, or perhaps retire them entirely. In a number of instances, the requirement simply doesn't exist in the same way as it did, and that provides certain opportunities in certain spaces. But there's also a bit about the technology you lay over the top of it. If you accept the limitations of those systems, and there is no opportunity to replace, using technology that is, to a certain extent, specifically designed to be able to get data out of those sorts of systems, and allow you to do today's things with it, the kind of things that you would expect as normal from a system you bought today. That's ultimately why we're in this position.
Brilliant, thank you. I'll try the room again. Any questions? Otherwise, I'll let online have all of the fun. We've got one there.
Alex Nice, Institute for Government. Are there anything which our allies or maybe adversaries, other countries with defence, are doing with data that you would like to do?
Inevitably. I think, yeah, that's a challenging one. That is a massive question. Particularly on the adversary front, right? So what they can and can't do with data is driven a lot by their perhaps social norms and what their governments are willing to accept and things like that, and what their society accepts or considers to be acceptable. We don't do some of those things, and we won't do some of those things. On our allies side, we regularly share with our international partners and allies, and that includes sharing not just kind of techniques and processes, but also in some instances tools, even down to code in some respect. So we are sharing, and wherever we identify an opportunity to basically avoid having to reinvent the wheel because somebody else has already got a car, then we will take it. And we are doing that today. What the specifics are, I might not talk about here.
Well, that's been great, Ben. Thank you very much indeed.
Thank you.
A few quick parish notices before I let those of you in the room to drinks and nibbles afterwards. First thing is that there will be a recording of this event available on the Institute for Government website within about 24 hours. You can, of course, watch it now as live at the link bit.ly/SlidoDB38. The next port of call for the Good Ship Data Bites will be on Wednesday, the 1st of March. That will be a health special, again, supported by Palantir. Lots of other events happening at the IFG over the next few weeks. I mentioned we've got an event on data sharing during the pandemic next Wednesday at 6 p.m. The next event is about levelling up. That's 1 p.m. on Monday. We've also got Patrick Vallance coming and a pre-budget briefing and the next performance tracker launch, all within the next few weeks. So go to the IFG website for more details on that, and of course to explore Whitehall Monitor, which I mentioned earlier in detail. All that remains for me to say are three very big thank yous. First of all, to you, our audience here in the building and online. Some brilliant questions tonight. A big thank you to Palantir for supporting tonight's event. And finally, join me in a huge round of applause for our fantastic speakers. Thank you very much indeed.